So this is our alternator production simulation. This is our scope. This is our subsystem. We have to build this block. So now go to Simulink, Simscape. In that, choose electrical. It's taking time to load. Yeah. To create a new file, you have to always go to Simulink, Simscape, electrical. Then I will take all the components that I require to create this subsystem. This is our subsystem, right? So we have here demux, RMS, relational operator, constant, flip-flop, AND gate, double type data conversion, everything. So in that, I'll go to library browser. I will choose all the elements that I require. I will take all the elements that I require by typing them in the search box. Only thing that I have to make sure is I type the spellings correctly for each and everything. So I will take all the components first. So now I got all the elements. So I'll start aligning them as per our circuit diagram. So first I'll connect our input to our demux. Ours is 3-phase system, right? That's why convert it demux into 3 output ports. Click OK. Then I will elongate it. Then after that we connect RMS to convert it into normal current, real value current I mean. So RMS, RMS, RMS. After RMS always comes our relational operator. In relational operator we check the voltage whether the voltage is 11,000 kV, sorry 11,000 volt, or is it reached below 11 kV or above 11 kV. That happens only during faulty condition. That's why I take relational operator. Then I'll connect this constant to relational operator and also RMS to relational operator to compare the values. So we connect RMS, then I'll connect the constant to all three relational operator side. I will change it to 11 kV or 11,000 volt because our generator rating is 11,000 volt. After a relational operator, I will connect it to our SR flip flop. So I will connect relational operator to our S side of our flip flop, all three phases. R, Y, B, three phases are there, right? That's why we are using three same elements like three relational operator, three RMS block, three flip flops. So then I will connect R input side to a constant, that is Boolean, and I will make that value 0. Here I will change it to Boolean because our electronics circuits works on Boolean values, that is zeros and ones. So I will connect this constant to flip flop. Yeah, now I want only Q output, right? But what we'll do with Q bar output, we cannot leave that open. That's why we terminate it using terminator. And I will connect all three flip flops output to the AND gate, because whenever the fault occurs it shows 0 output from our Q, and whenever there is a 0 in AND gate the output becomes obviously 0. And we have three phase, right? We have three flip flops, that's why it's three inputs. We go with the AND gate. Just enlarge it. Data type it's Boolean once again. Yeah, first flip flop, second, third. Now we'll convert this into double because our AND gate gives Boolean output, right? But our circuit breaker works on real time values, that is double. So I'll connect double to output side. Now to create a subsystem, I'll select everything like this way. Yeah, now after that we can see three dots there, right? Then we see there create subsystem. Click on that. Now our subsystem has been created. I don't want these two elements, that's why I delete it. I am only interested in subsystem. Yeah, now I got our subsystem. So it's time to create our main generator, circuit breaker, measurement and load block. So I'll always choose the generator. So I will take simplified synchronous generator, that is simplified synchronous machine SI units. In the same way, I will take all the components that I require. Now I will connect all the elements as per our circuit diagram. So first I will connect constant to PM, and then I'll connect the same constant to excitation. So to our circuit breaker has to be closed in position, and I'll click external because the circuit breaker should operate only with relay, right? So then we'll connect as per the circuit diagram each and every block. I am taking DMUX block because our system is three-phase system and we need three output waveforms RYB phase in the scope. To check that, we convert DMUX output ports into 3. Click OK. So then I'll connect M terminal to the DMUX input side. Now I'll connect the scope. I need 3 input terminals, right? So to get that, I'll double click on that scope, come to file, number of input ports, that is 3. Yeah, good to go. So just enlarge it, then connect DMUX. To rotate any element, use Ctrl R. So now we'll connect our relay output to circuit breaker. Now I'll connect our three-phase fault into our system, and I'll click on external because the fault has to be created from our state generator. So I'll connect ABC. So now I'll connect our state generator to a three-phase fault. So I'll double click on the state generator. Then I'll take only two time instant, that is 0, 5. Then here also I'll take only two time amplitudes 0, 0 in initial position or initial time. To create fault, I will make it 0, 1. Click on save. So to run now, click on run. Now it started simulating. So to check the output now, we'll double click on the scope. Yeah, we have output now, normal voltage output of 11 kV. So output side also normal after our VI measurement block, that is after our circuit breaker. Now I'll create a fault using state generator. So to do that, what I will do, on the amplitude I'll just change 0, 1, which means in the 5th second I'll create a fault. Click OK. Now once again run. So now you can check the output from our scope. So double click on the scope once again. In the 5th second we have a fault, so we'll see the voltage waveform. See, the voltage has been spiked because of the fault. Okay, now we'll see after VI measurement what is the voltage we'll get. Yeah, see, after 5th second our relay has been operated, our circuit breaker has been operated, so that's why the power has been shut down after our circuit breaker. So this is our simulation of our alternator protection scheme in Matlab. Okay, anyway, thank you.